Hello everyone, my name is Jimmy and I'm here with the Health PEI team with Morgan and Tom. So to show a SolidWorks rendering of our device, we first see that our device plans to use a practitioner's existing smartphone to capture images or videos through an otoscope clamp. It utilizes an existing adjustable phone clamp and a flexible gooseneck to allow for any variety of smartphone to position itself within the lens of the otoscope. The 3D printed clamp perfectly conforms to the outside of the otoscope handle, and the cam latch allows for simple tightening and loosening to clamp on to the otoscope itself.
The Otoscope smartphone adapter should work with a smartphone to consistently capture high-quality images or videos of the inside of the ear. The design should only need one hand to operate to make sure that it will not interfere with observing or examining the ear.
We have a little demo here to show the functionality of our design. So first, to the base of the otoscope, the handle can simply slide on top, and the cam latch can be used to crimp onto the edge of the otoscope handle. From there, the adjustable smartphone holder can be opened or closed to fit any model of smartphone. At that point, the smartphone is fixed in its position, and now the flexible gooseneck can be moved around to adjust such that the camera can be positioned perfectly in the angle of the otoscope.
Here is an example of the prototype of the adapter being used with one hand, with the other free to move to either adjust the ear of the patient or take a picture or video on the phone. We were also able to observe and capture clear images of the ear canal.
Throughout the development of our design, there were various analyses that were completed. The first of these was a SolidWorks simulation that determined the amount of force that would be applied to the otoscope clamp. The second was to determine the amount of torque that would be applied to the gooseneck, and the third was a spring analysis that allowed us to confirm that springs would work for our design, and that ultimately led to the development of using a rack and pinion gear set. 3 separate tests were also performed. The first of these was a gooseneck weight test, which involved adding weight to the end of the gooseneck until it started to bend. The second was a gooseneck creep test, which measured the change in height over time. And lastly, the clamp stress test that was performed, which found the safe operating force of the clamp. I'd like to acknowledge everyone that helped us with this project. Thank you to Dr. McDonald and Health PEI for the opportunity to work on this project. Thank you to Dr. Sandeep Singh and Dr. Kuljit Gruel for instructing the course. And lastly, thank you to all the UPEI technicians and everyone else who helped us with this project. Thank you.